Good evening, everyone, and welcome to last session of day 4. In this session, we are going to analyze an efficiency of trained machine learning models. Okay. First of all, we'll try to understand what is machine learning model. Uh, it is a mathematical model. It is having some mathematics and learning. Learning means what we are doing some adjustment. What adjustment? We are adjusting the parameters in that mathematical model. So inside there is some parameters, and if we adjust the parameter, that means our model has learned something. However, there are some parameters which are known as hyperparameters. Okay, they cannot learn directly. So in order to make them learn, you have to do some explicit task. Okay, so these parameters actually exhibits importance uh, in the learning, because if we take one simple example, uh, say a classification example we have, and we have data items like this. And we are asked to do a classification. So simply a linear line, with the help of linear line, we can do classification. But in real life, data are not like this. Data are scattered, they are mixed. If we have data like this, then in order to do classification, it will be very difficult for us to classify with the linear line. So this becomes a non-linear classification. So if we use a support vector machine over here, so we may have to do classification somewhere like this. So there is a various curve involved in it. So to decide, I mean, the parameters which are responsible for deciding the curvature of the classifier, okay, those are known as a hyperparameters. So here in this session, I'm going to deal with the support vector machine. So we have parameters like C and gamma. Okay, C and gamma, these parameters I'm going to tune for learning. So C, we can have, see, we have some values, say 0.1, 1, 10, for example. These are range of values. And gammas can have some, say, value like this 1, 10, 100, and so on. So we have two parameters. Let's say we are working on these two parameters. Then the two parameters have various values. So if we analyze, then we are going to generate a grid like this. So if we are trying our model by fitting the parameters C and gamma, value 1 and 0.1. What is going to be the result? We have to check. Then 1 with 1, 1, 10, 10.1, 10, 1, 10, 10, 100.1, and so on. So this is nothing but a grid. Okay. So here the main idea of is that create a grid of hyperparameters just like this and try all possible combinations. This method is called as a grid search. Okay, so but we don't have to worry about this kind of trying all the combination, because scikit-learn has a functionality built in named as grid search CV. Okay, this grid search CV, it takes a dictionary that describes the various parameters, okay, and which is going to be tried on the model to train it. Okay, the grid of parameters is like a dictionary where keys are the parameters and the values are the setting to be tested. So let's start this thing with our experiment. So here I have taken inbuilt data set, breast cancer data set from scikit-learn. So first of all, I import all the necessary modules, pandas, numpy, scikit-learn metrics, importing classification reports, confusion matrix, and the data set we are loading breast cancer data set. And since I said we are going to use SVM, so support vector classifier, importing and loading this data set. Okay, so let's see this, what is there in cancer.keys. So the data is arranged in the dictionary form. So we are just extracting the key values. What are the key values? And it is like this. So in cancer dataset, we have these many key values. Okay. So now first step, what we will do, we will extract all features in new data frame. Okay, and extract target into separate data frame. So we'll begin with this. So with the help of pandas, so pd dot data frame, and we have a data cancer. So it is there as a key over here. So that's data I'm taking over here, and I'm including all the columns. Okay. So columns, I'm taking all the features of cancer dataset. Okay, so this data frame is done. Then we store into some variable, say df feature. Now, cancer is our target column. Cancer column is our target. So we also make a data frame for target. And here, so only one column. Okay. Let's print feature variables. And in previous session of pandas, we have seen if you want to describe any data set, we just use either describe or info. Describe only shows the statistic part, not the non-numeric data. So better we will go for the info. Okay, so we will describe our feature with the help of info. Let's print this. So this is describing the data set. Okay, it is having a total 30 columns, and every column it is having a 569 entries. So all 30 columns are listed just like this. So that means somebody has done all these study on all these parameters and he has uploaded. Okay, that's all. Let me copy this. Yeah, I'm sharing code. So this is the step one where we will load data set and then we will try to duplicate data set by making our own data frame. So one data frame is having all the feature values, and the second data frame we are taking only the target value. So which is done over here. Please try it at your side. Before analyzing or analyzing the efficiency of a machine learning model, first go through a data set and see all the parameters, all the features, all the entries, what is the target, and then we will go for the applying support vector machine model over here. Check karo. Okay. Okay, participants. So I will move to now next part. After getting a data set, no, we have made two different data frame. One data frame is having all the feature values, and second is having the target value. So what further? Now we will train, test, and split. Okay. So next step. So from sklearn, here we use model selection. And in that model, we have train, test, and split. Okay. So for see standard notation, X we take as an input and Y we take as an output. So we will split over here 70:30 ratio, say 70 for training and 30% for testing. Okay. So we have input X. So X we can divide it as a train data, train, and test. And we have output, say Y, we divide it as train and test. So four parameters: X train test, Y train test. Okay. And we are going to call the method train. I'll simply copy this: train, test, and split. Okay. So this train, test, and split is going to apply on some data set. What is the name of? Okay, Mohammad Beg is saying share the first part of the code again. Okay, let me check. It is already there, visible in my chat box. So I'll copy this only and give it to you. Okay, Mohammad, now you can take entire code. Okay. Okay. Now, I have to split the data into training part and testing part. On which data? So I have to provide that data name. So I will go on top and I'll see what name I have given. So here, as you can see, all the feature values. So these are the input. No, feature names means what? Input. So these are all these things over here. So I have given the name as df underscore feature. So I'll use the same name over here. So df underscore feature. Okay. Then there is one method named as np.ravel. In that, I'm going to pass the target. So just like I said, I have created two frames, no? Two data frame, one for taking all feature values and second for taking only target. So the target one I'm keeping in the Ravel function. So df underscore target. Okay. Closing it. Now, what is the job of this Ravel function? Actually, we have entries in the multiple dimension format, like say matrix format. So we have one row, then second row, then third row. Okay. So this Ravel function, what it does, it takes entire, say, two-dimensional data into one contiguous location. That means one single array, it is going to convert everything. Okay. It is used to change two-dimensional array or multiple dimensional array into a contiguous flattened array. So consecutive elements. So you will not have to move two index, row and column. Over here only one index, and that to continuous data. So here this Ravel function is used for converting multiple dimensional data to a contiguous location. So flatten. Okay. So this after taking input, flattening the target, then we have to say how many how much data we have to do for testing. Okay. So I said we will use 70-30 pattern. So test size, I say 30%. So 30% comes 0.3. So like 0.3 over here. Okay. Then there is one more most important attribute of this method, and without it you cannot train your model. It is very important, and its name is random state. Its name is random state, and it is you can keep any value, some non-zero value. So I say I'm keeping 101 or 100, whatever you want. So let me explain what is the meaning of random state, why it is used. So I'll take one example over here. Let me run this code first, and then I will go a little bit away from the topic, and I will explain only random state so that you will come to know. See, if we have a huge data set and I'm dividing a data set into a training and testing part, then say 70 and 30 is done over here. Then those 70%, if I do first time, okay, then the same element, if I do second time, will remain the same. It should not change. So if it should not change, then in that case, you have to pass attribute random state as some value. So we'll see over here. Let me give this code. I'm just now explaining the random state and this Ravel as well quickly. So in this cell, then I will remove this part. Say I have a entry, say X value, and NP array, and having first entry as 1, 2, and 3, first row, and second row, say I have entry as 9, 4, and 6, like this. So these two are in one matrix A, therefore it is kept in the bracket. Okay, so this is one entire data set over here. Now what np dot Ravel will do over here. Okay, so let's store it in some variable, say y, and see what is y. Now you can see over here, this is what, this is two dimensional, no? Two rows are there. what Raul has done, it has kept everything into a single contiguous location. No, in other words, you can say it has flattened the input. So here the target value df.target, df underscore target is going to be made into one particular array. Okay, now when it is made, when it is flattened, no, so its data type of the elements are not changed. They will remain the same. Please mark this. So this is about the Ravel function. Let us move ahead and try to find out what is about random thing. So I'll remove this part over here. Say I have two things, so A and B, and first A, I take it as NP in dot A range. Okay, that means 0 to 9 it will take, and then I have to arrange it into the form of a matrix form, no? So reshape. Now reshape, under that I have to pass the dimension. So that dimension should not change. Therefore, I have to include over here tuple. So tuple and size is 5.2. Okay. So this is the first one, A, and then for second, let's take only range 5. So 4 values I'm going to take, 5 values 0 to 4 going to be taken. After doing this, we will call our simple train, test and split. Okay, so we'll call it. Better let me do it in separate. So let me run this first. Okay, then A and B generated, then train test split in bracket A comma B. Now let's see this. Okay, so it is having a separated the data like this. This is one output over here. Again run this. Again run this and check whether this separated thing remains the same or it varies. Compare these two. So it is not same. It is not the same. So there has to be something which is going to stop changing. Okay. So let us say I'm going to pass random state now. And I can give any value, say any non-zero value, say I'm given 1 over here. See this one. And again try. Now compare. So it is not changing. So once you introduce random state, then the training part and testing part will remain same. Therefore, random state is very much necessary to include in train test split method. All right. So now we'll go for the next part. Let me share this code as well. This is just to check random state function. All right. Now, see, after train, test, split part we have done. We'll move to next step, and the next step says uh, train the support vector machine, support vector classifier over here. Okay, and when you do directly training the support vector classifier, that means the parameters in case of support vector machine C and gamma, they are not tuned explicitly. They are inside. Okay, the grid is not formed and that grid search is not done. It is going to take the random value of C and random value of gamma and put in the. So we'll see what will happen in that case. So we will call model support vector classifier, and then we'll fit it. So model dot fit, where we have to fit in the input and output, no? So X train and Y train. So this is in the training set, no? So we are fitting this. Saima ma'am, support vector classifier, no? It is just like a classifier. If you at beginning I have explained, no, this thing. See, we have two sets of data, green data and a red data. Then and the problem is of classification. We have to segregate the data points. So support vector classifier intelligently make the boundary line between the two set of data or multiple set of data if it is there. So internally it does that only. Yes. Then there is a lot of lines will be there, no, creations. So everything we will go for, in order to find out the difference between the various set of datas, we will go for complex mathematics. We will call Gaussian functions, okay, and various input set of parameters, so that we have not with the single line, we are not able to do a classification. We have to introduce multiple factor. So that, for example, if we have a data yellow one as well over here, yellow, then what? Then I need a separate line, a different line, which is doing the classification like this. So parameter is changed. These are all the hidden one. So that this hidden thing which is controlling the classification, which is managing the classification, the parameters are known as the hyperparameter. So I will come to that part once. Without tuning this parameter, we will see classification, then we will tune it, and then we will see again what is the result of that tuning. Sama ma'am, I hope I have answered your question. Okay. Okay. So here now this algorithm is already inbuilt. So I'm not doing anything special. I'm just simply calling it and fitting in this. Okay. So what fitting? The training items. And then I have to do predictions also. After fitting, I have to do a prediction. So model dot predict. This is for doing the prediction. Prediction on what I have a test data set, no? So input. So test is given as an input, and then it is going to give some output. That output is nothing but y, no? So here we say that is our prediction. So we'll write over here prediction. Predictions it is going to do. And then we print it and we'll check what is the prediction. So classification report we will generate, and we check it with the help of y-test. And predictions, what we got. Okay. Okay. So we created a model, not created, we imported a model. We fitted our data set into that model, and then we have done some prediction with that model. And finally, we have compared with the result. So we got this thing. Let us see this report. Let's see this report over here. This is saying 61%. And if you observe, no, for 0, that means here the target values are, the classifying only 2 parameters, 0 and 1. Okay, either it is 0 or it is 1. In 0th entry, all the items are 0. So that means this classifier, support vector classifier, it is taking all the data points and putting into only one class, that is 1. So it is not successful enough to classify the item properly. With this report, I can make out. That means the data is non-linear completely. Okay, it is non-linear. So here we have to tune the internal parameter of support vector machine. Okay. PNR are 0. Which PNR, ma'am, you're saying? Yeah. So it is, that's right. No, yeah, this PNR. Okay. So that means this is not the correct classification. So we need to do something. No, here you can say it is giving almost 61%. It's not good. So we can we further maximize with the help of tuning some internal parameter? Yes, we can do that. So so here comes the role of hyperparameter, and in order to deal the hyperparameter, we make a grid of various value, and then we will do the grid search. That means we will go either in this block, taking these 2 value, and check the result. Okay, then we will move further, go in this block and check the result and compare with the previous one. Similarly, third, and so on. So at the end, we are going to see all the possibilities of these parameter values. And finally, we will get the best value. And that best value we will put into the model, fit it, run it, test it, and then we will see again, is it going to give us the desired output or not. So this is nothing but a grid, and we are searching for finding the perfect tuning of this parameter. Therefore, It is also known as a grid search. Okay, so we'll go for the grid search. So here we have grid search CV inbuilt. Okay, so from so again in model selection, we will import grid search CV. Okay, we have imported this search. Now this search should, in order to make it work, we have to create a grid as well. So how to create a grid and which parameters we have to take. So we will write over here parameters. And since we are doing it on support vector, so support vector classifier, it is having two parameters, C, and we are taking it in the form of a dictionary. Okay, so values, say I'm taking say 0.1, 1, 10, 100. Okay, see what happened, no, when you do classification manually, sometimes you keep C value less, you get better result. Sometimes C value very high, then get better result. Sometimes it is in between. So it is totally depending on the data set, the value, which value of C should be taken. Okay. Then the next one, gamma. And kernel. So here it is using a Gaussian radial basis function. So RBF, to deal if there is a more complexity and more randomness. So using the Gaussian kernel over here. So RBF. So this is nothing but the making a grid of hyperparameters. So for simplicity, Saima, I'm giving the value in 10 form only. It can be any decimal value. It can be any integer value. So I'm making a range from 0.1 to 1000 over here, and this is 1 to 0.001, or I can keep the same value. Okay. Grid search is only for here SVC, support vector classifier. It is no, in this case it is for SVC, but you can have other classifier also, and in that classifier you have to find out the mathematical detail and what is the hyperparameter in that classifier, which can be tuned with the help of grid. So this grid search is just searching in a grid. So it can work for others also. Okay. Have I shared this code over here? This one. Let me check. Okay. So C gamma kernel, these are SVM parameter. Thanks, Dhammajyoti ma'am. Yeah, these are SVM parameters. Okay, so now we will call grid search over here. And this grid search is using which classifier? Now with this, I think you will get your answer, Saima ma'am. So here you will pass the classifier explicitly. So very first parameter will be the classifier. So which classifier you want to test over here in this case? SVC. Okay. Then what is the parameter? So here you have a parameter grid. So you'll pass that. Now, as I said before over here, you will first do this grid search. You will take out first option, you will put in the model, get the answer. Then again, you will go for this second option, put in the model, then third time put in the model. That means every time you are going to fit. So therefore here, the next attribute is refit, and you have to make it true because you are several time you are doing iteration and again you are fitting. Therefore refit has to be true. And then there is one more parameter, verbose. It is giving the explanation of the classifier at the end. So generally you keep it high. So keeping it over here as value 3. So this is grid search CV, okay, which is searching and fitting. Just rename it as grid. Next. Then in grid, we got the detail and we got the best pair of hyperparameter from this grid search. No, from this grid search CV, we will get the best hyperparameter in the grid, and with this parameter value, we will try to fit in the model. So grid dot fit on the training data set. So now you can see over here, there is various scores. That means all it is going through the grid and taking out each and every combination, putting in the model, finding out the score. Okay. Yeah. So just try out this one at your end, and then we'll move ahead. After executing code, I got different value from your result, and also got like accuracy. It is because of the randomly selecting data set, ma'am. Accuracy is same, no? Yes, ma'am.
Accuracy, I got like 92%, sir.
How much?
92, sir.
92.
Yes, sir.
With the same code.
Yes, sir. Just I have copied and paste.
And what about the classification report?
Yes, sir. It is like precision value 0.995, recall 0.85, F1 score
Okay.
0.90.
Okay.
Like that I got,
And
sir.
what about the zeroth entry? Like here, I got all zero.
Yes, sir. For that only I got 0.95, 0.85, 0.90 like that, sir.
That means you in your Python model, uh,
Okay.
whatever version you have, that is tuned one.
Okay.
Tuned one. Yeah, I'm going to cover this part.
Okay, sir. Okay. What is that about macro average, all these parameters, sir, including accuracy?
Just a minute. Let me check my side.
Yes.
Ma'am, you just try this one, which I have just pasted now,
Yes, sir.
and check the accuracy again. Once you tried this, after trying this, uh, now you can inspect the best parameter, which is found by the grid search. So we'll inspect it. So let us print it. And estimator also will try to check. this is just tuning. Okay, best parameter. What it says C value is 10 and gamma value is 0.0001. Okay, on this combination, this model is going to work very well. Okay, so this is just a result of the inspection. So we are going to see its actual result on the classification in the next one. So we will put in the predict form. So grid dot predict on X test and say it is we name it as grid prediction. And after prediction, we'll put a classification report as well. So print it. So test output and what grid prediction we got. So let's see this, whether it works or not. Okay. So if you compare the previous one, what previous result said, class 0, all entries are 0 over here. Okay, and class 1, it is giving some value and the precision saying 0.61 at 1. Okay, and average, after getting average, this is the result. Coming over here, after tuning the hyperparameter and then again applying it and fitting. So now we have achieved that accuracy is 95%. Okay, 95%. Ma'am said, can you please scroll up screen to see something? Okay. Is it okay, ma'am, or further? Okay. Okay, got it. Okay. So in what is the gist of the session over here? Okay, I'm sharing the remaining code. Let me share the remaining code. Okay. Okay. So what is the gist of the this session? It is that when you use a classifier, you try to train your model. Then in that classifier, there are certain hyperparameters involved. Those hyperparameters needs to be tuned explicitly in order to give you better result. I have just shown you the comparison. In my first run, I got accuracy as 61%. And when I tuned my hyperparameter, I got accuracy as 95%. Okay. So what you learn from this session is that your tuning, how you can do a tuning with the help of a method named as a grid search CV. Okay. Okay, Simon ma'am is saying, what does a support means? This is ma'am efficiency parameter. The exact exact mathematics behind this I don't know, but thing is that if you have a higher value of support, that means it is better. Like F1 score, there is some mathematics involved. Okay, so all these are having some inbuilt mathematics, so one need to go through it, and based on that fact only I can answer, ma'am. Yeah, the only thing that all this parameter needs to be maximized for getting better result. Yeah, so here I just want to add a few more points in the theory part. So all of you know what is the formula for Gaussian function. It is nothing but the exponent of then minus then the difference of data x minus say x dash divided by 2 sigma square. Okay, so this 1 divided by 2 sigma square, you can take it as a gamma. This is the gamma parameter. Okay, so in order to find out better result, you can think gamma value has to be minimum or it has to be maximum. Can anyone answer that? I have given you formula. Like I'm moving from programming part. I'm just going in mathematics. I'm just saying that Gaussian function is saying exponent of minus x dash divided by 2 sigma square, where 1 upon 2 sigma square is gamma. So in order to get better classification result, okay, gamma value has to minimize or has to maximize. Okay, okay. Mohammed Beg is saying minimum. Yeah, maybe minimize. Okay, okay. You both are right, correct. But if you recall my beginning, beginning, like in the very beginning, when I was explaining this hyperparameter, at this point, what I said, sometimes it is maximizing, sometimes it is minimizing. So the maximum value and minimum value, it is going to vary from data set to a different data set. So please don't make a common conclusion. So the idea behind this question is the same only. We cannot be judgmental about it has to be low, it has to be high. What we should do, we should just tune it by providing grid search CV. Okay, so tuning is done internally by using a grid search, and the best result is taken then. Okay, participants. So that's all for this session.
Thank you, sir.
Thank you. Thank you.